think there are at least one or two people who don't know me. I don't know how that occurred, but my name is Rex Macy. I've been hanging around here a very long time. And I sort of came up with today's event. I'm shocked to see how many people have attended. There are more nerds here than I thought. Thinking about what I was going to say, I remember when I started, and literally, I predate Excel. I started using spreadsheets in the VisiCalc Lotus 1, 2, 3 era. And I remember the power, the joy of the power when that first spreadsheet ever used. It was amazing, an amazing feel to think how easy it made some of the analytics. When I became familiar with R, and as I learned R, that brought me the same sort of sense of joy. And for those of you who haven't experienced that, I encourage you to try it, and that's a lot of today's talk. Out of curiosity, how many are using R now? So just a few. Good, so we have some virgins. That's nice. What I love about it is the analytics, the reproducibility, the publishing. All of that is great. And to give you one more thing that I think R has that I feel when I'm in this room with the Atlanta Society, and that is a sense of community. R really does have a community and a great deal of support, and that's very hard to duplicate. It's one of the reasons why you would wear a shirt like this. So that brings me to today's speaker, Jonathan Regenstein, and you may, if you think of Ned Davis Research and the old brokerage firm that was a sales arm, it's the same family lineage. He leads the financial services practice at RStudio and works with data science teams at a variety of financial institutions. He studied international relations as an undergraduate at Harvard, worked in finance at JP Morgan, and then did graduate work in political economy at Emory before joining RStudio. He's the author of the forthcoming book, Reproducible Finance with R, to be published. Has it already been published?
The next few weeks.
Next few weeks. His code and shiny apps can be found at reproduciblefinance.com, and I'll make a plug for his employer. As I mentioned, the community. If you use R, you're very likely to use RStudio as your IDE, as your development environment. RStudio is free. They have been great in supporting R, and Jonathan works for R. So with that, Jonathan, thank you very much for being here today.
Thank you, Rex. That was a very enthusiastic introduction to R, and I will make a note of it on my social media accounts. Best introduction we've ever had. All right, well, thank you everyone for coming. Much like Rex, I am thrilled to see this much excitement about R. You never quite know how many people are going to turn up to spend their lunch talking about data science and coding. So thank you all very much for coming. And let's get to it. So we're going to talk about data science for investment management with R. And I was sitting at the very back, so I know it's going to be kind of hard to see what's on these slides. And I will send all of these out at the end of the presentation, so everyone will get copies of these. It's going to be kind of hard to see these. I can tell this is a little small, but we'll just do our best. All right. So first, Rex just gave a pretty good introduction to RStudio and R, but I just wanted to say a few words about what it actually is. So R is a statistical programming language. It was born about 25 years ago in New Zealand. It derived from S, which had derived from C. We like to say that it's by data scientists for data scientists, meaning it's not a general purpose programming language. You would never really want to build an entire website out of R, but the good news is that makes its syntax and its logic much simpler and easier to pick up because it has one purpose, and that is analyzing and visualizing data. Okay, so we have base R, that thing that was born about 25 years ago, and we have a package system that sits on top of it. Currently there's about 17,000 packages for R. And you've probably heard that R is an open source language, and what that means is that people can contribute to it and make the language bigger and better and more intuitive. And you do that via packages. So at the end of this talk, if anyone here had an idea for a package for R, you could go and you could build it, and you could make it available to everyone else in the R community, and they could start using it and then building on top of that. So the power of R kind of builds exponentially. As more packages are built and more people use them, more people use those packages and build more packages. And that really leads into a lot of the fun and a lot of the enthusiasm about R, because we can all contribute to it, and we can all make these packages as intuitive and as easy to use as we want. And of course, not all packages have to be published. Almost all of the quant teams that we work with build their own proprietary packages that sit behind their own repositories, and they're almost creating their own little R environments, and sometimes they'll open source and publish maybe just a subset of what they're doing. But for the most part, people are building and publishing these packages. So I work for RStudio, which is a company, but it's also an IDE, and here's what my IDE looks like. IDE stands for Integrated Development Environment. But you can just think of it as where people come to import their data, write their code, build their models, maybe collaborate with other coders. So that's what RStudio is. But we also build a lot of those open source packages that people tend to use. The most popular of which are sitting in a thing called the tidyverse. And this is an example of something from the tidyverse called ggplot. And that oftentimes leads to some confusion of where does R end and where does RStudio begin, because we have a development team at a company that gets paid to build free packages that we make available for free. And people can't understand why we would do that, so they think we must just be part of R. But in fact, it's just to kind of build the community. As Rex was saying, it's a very strong community for building and publishing things just to make the environment better. We also build a technology called Shiny. And Shiny is kind of one of those words that if you start to get into R, you will hear it come up a lot. It's an R package that was developed by Joe Chang, our CTO. There's a whole website dedicated to Shiny. And what Shiny does is it allows you to wrap your R code up into something like this. This is an interactive dashboard. It's basically took some of the analysis that I ran a little while ago and made it interactive. So it translated all the stuff into HTML and CSS and JavaScript, which means that as R coders, we don't have to learn any of that stuff. Shiny just kind of does it for us. It's a big piece of the tool chain. It's been driving a lot of the recent popularity and adoption of R. And if you start getting into R coding, I definitely encourage you to make Shiny a piece of that, because it will really be the place where we're communicating our work to people who really don't care that the source code for this thing was all written in R. Most people just kind of want to see the results. Right? And I know it's hard to see it up here, but these are just some charts. And this is how most people are going to be interacting with our work. I'll just round out some other pieces of the R toolchain so that we're all kind of on the same page with what's going on here. R Markdown is a technology for building PDFs and HTML reports. There's a variety of database connectors, which we built last year in response to people saying that R can't really come into production unless you can really quickly access databases. We have a technology called Sparkly R, which is sitting right here. So if anyone's getting into kind of big data, machine learning, computing, you'll probably at some point end up wanting to push a lot of your compute out onto a Hadoop cluster. And Sparkly R is a technology that we wrote to translate your R code into the Scala code to do that. Similar story with TensorFlow. This was a collaboration between our founder and Google Brain to build R hooks into Google's TensorFlow libraries. And there's kind of a common theme between Shiny and Spark and TensorFlow, which is that as R coders, we never have to leave the IDE where we're writing R, and we're just working with our data. But in the background, these packages have been built to make available to us web dashboards via Shiny and translating things into Scala code. So R can really be almost like the gateway to a big universe of computing, but we don't have to get into all that general purpose programming, which is very nice. Okay. So that's kind of the R tool chain. Let's spend a minute on just data science in general, not specific to finance, just data science and how we think about it. And this is really the paradigm we've come up with. Our chief data scientist who came up with this likes to say that, I don't know how many words are on here, maybe 20, but it probably took us 2 years to really come up with this as a way to compactly describe a data science paradigm. And it starts with this thing, data imports, which can be frankly the hardest and maybe the most frustrating thing when you're first getting started. But it's a really important piece of what we do, and it's also one of the things that I think is helping R gain popularity because the data import tools are becoming very intuitive and very fast for importing things like Excel files and CSV files. Rex mentioned reproducibility, and this step right here, import, it's really tempting to kind of gloss over that and just give me the data and let me start working. But for your work to be reproducible, for anything to be reproducible, this step is just crucial. How we got our raw data into this IDE. And we kind of like to jokingly say at RStudio that there are very important collaborators out there for reproducibility. There are our colleagues, potentially our clients and customers, possibly auditors someday. But there's also our future selves. And this paradigm was really written with our future selves in mind, because in 6 months, when you open up this, which has got a lot of code in it, even though it's broken up fairly into chunks, your future self might have forgotten where your data came from. So you want to make that really clear in your data import section, and R has these nice packages for doing so. Then we have this tidy transform thing here. You'll often hear this referred to as data wrangling or data munging or pre-processing in the machine learning world. And there was some New York Times study a while ago, I think it's a bit apocryphal, that data scientists spend 60 to 80% of their time just wrangling their data. I don't know if that's true. I think it's kind of on a project by project basis, but it's a really important thing. And R has a lot of nice tooling to make that intuitive for us and intuitive for others who want to know how we got from our raw data to the data that we're working with. So this step also is very important. It can be a little bit painful. This import and wrangle step, I think it probably just feels like it takes 80% of our time because really no one's going to ever see it except for ourselves, maybe our collaborators, right? Because going back to like this Shiny app, there was a lot of data wrangling and import that underlies this, right? This sampling thing down here took a lot of wrangling. No one really cares though, right? They just want to see the end product. Which brings us to visualization. So visualization, if we can leave here today with nothing else in our minds besides visualization, I'll still be very happy because this is a very strong and fun part of the R toolchain. There are a lot of really good data visualization packages out there. And I find, particularly with a lot of the quant teams that I see in industry, that visualization tends to be the piece that doesn't get as much attention as the other pieces. There's a lot of firepower focused on modeling and predictive analytics and potentially looking for alpha or just relationships between variables. And the visualization seems to be the end piece where things just kind of get plugged out into a standard chart. I mean, last week, in fact, I was up in New York at this conference. People were talking about all this crazy machine learning stuff they were doing. It was pretty interesting. And I could tell these guys had spent months on their algorithms looking for these interesting little relationships between ETF flows and possible price movements. But at the end of all their talks, they had one little chart as if they had spent nothing on it, and no one remembers the code. Everyone just remembers the charts that they put up. So, plug for data visualization. Then we have modeling, which this is probably where things get a little bit more proprietary in finance. People tend to use their own models for a lot of their work. All right, so we have the R tool chain and we have data science. That's just kind of a general overview, nothing really specific to what we're here to talk about today, which is finance. Probably hard for you guys to see that, but that's okay because these are just the names of packages, which I'll send out to everyone. It's a good example of the package ecosystem, though, in R, because people have spent a lot of work, years of their life, building these packages and making them free and available to us to make our lives easier for analyzing things in the financial world. We're going to look at some of the built-in functions from performance analytics. It's a great package. It was built by a team out of Chicago back in 2008, so it has had a 10 years track record behind it of people using it, testing it, reporting bugs, having the bugs fixed. As Rex was saying, the R community tends to be very collegial and supportive. You can straight up send a message to the people who build these packages who tend to be full-time professionals working in finance. I think one of these guys works at William Blair, the other ones are at hedge funds. I'm sure that if you emailed them about other stuff, they would, or at least if I emailed them about other stuff, they would never respond to me, but if you ask about their R package, they reply right away. For some reason, people want to help other R coders. It's a really interesting thing. So we're going to go through some of the functions for performance analytics, just because they're so nice and they really show off the package system well. The other ones that are up here, portfolio analytics. This is really nice for mean variance optimization, especially under constraints. TTR is a kind of a poorly named package, but it's for technical trading. You wouldn't really know that if you didn't know that you were looking for a package on technical trading, but I guess TTR is for technical trading rules. TinyQuant, this is a good example of almost like a meta package in the sense that it was built to help us apply these three other packages in an easier and more intuitive way. And it's a good example of that exponential growth of R because performance analytics has been around for 10 years, and TinyQuant came around maybe a year and a half ago, and it doesn't really have any substantive functions in it, but it helps us apply performance analytics in different ways. So the ecosystem kind of keeps building on itself, keeps getting bigger, keeps getting stronger. Like I said, I'll email all this out, but there's a link down here to all the packages for finance. Here they are. There's a lot of them. I mean, there's a whole package called yield curve. I guess that's for fitting a yield curve. There's a whole package called Sharpe ratio. There are a lot of packages out there with nice intuitive functions for us. And almost any project that we want to take on, there's a good chance someone has at least started working on it and going to give us 90% of what we're looking for. And then it's on us to kind of use our creativity on the next 10%. All right. So I said I was going to harp on data visualization, and I am going to do so. Here's just a couple of data visualization packages that if you want to get started with R, it's good to have these on your radar. ggplot2 is by far the most popular visualization package out there. It's one of the ones we build at RStudio. GG stands for Grammar of Graphics. People ask us about that a lot. Why'd you choose such a weird name? I don't know why. That's the name that our chief data scientist chose a long time ago. He would probably say he's very serious about data science. He would say there's a specific grammar to doing graphics, and this incorporates that grammar. So there we have the name. dy graphs and high charter. We're going to look at some examples that'll show what these actually do, but they're hooks into JavaScript libraries, which means that, again, we don't have to leave the comfort of the R world to build interactive visualizations. I didn't put leaflet up here, but you can do the same thing with maps. You can build interactive maps pretty quickly from the IDE. And Shiny is the one we talked about before, but I like to re-include it in visualization because it's really a visualization package. All right, well, let's take a look at R in action just a little bit. So this is just a toy project. Say we want to analyze and visualize data for 5 ETFs. And we would think back to that data science paradigm where we want to import our data, wrangle it, create some visualizations, maybe calculate some statistics of interest, get as far as we can with our built-in packages, and then we'll see how to create our own functions in a few lines to maybe take a look at a 50-day moving average versus a 200-day moving average and see if we're noticing any interesting trends there. So this is kind of a fast example just to show some different pieces of the tool chain. All right. So we're going to work with these 5 ETFs here, SPY, EFA, IJS, EEM, and AGG. And if we want to go out and grab the prices for those, we're going to create a vector of those tickers. And I kind of hesitate sometimes to put a vector on a slide, but I did so for a reason, which is to make the point that R is a vectorized language. So very similar to how the column of a spreadsheet can be thought of as a vector, R takes in vectors as arguments to its functions. So here, if we create a vector called symbols, we can then pass that vector into our function that's going to go out and grab these prices. So very similar to how you can think about the columns of a spreadsheet. You can almost think about vectors in R that way. Okay, then we pass these guys, we pass symbols to TQGet. That's just a function that's gonna reach out to Yahoo Finance. We're gonna use public data here in the real world. That would be very rare. Probably would never happen. Actually, this would be some sort of a call out to a database. But for just exploratory work, calling out to Yahoo Finance is going to be fine for us. And we're going to get something like this: the daily prices of these ETFs for the last 5 years. Okay, so a pretty quick and easy way to bring in prices. All right, so I like to go visualize things right away, and I like to do it with dygraph because it's so simple. It's just one word, dygraph, and then our prices. And we get this chart, which isn't really all that complex. It's interactive because it's a JavaScript-based chart. It's translated this into HTML for us, so we can zoom in on things. The reason that I like to start off with a chart like this is just to see if there's any holes in our data, anything weird. If there was like a big gap in one of these dates, we would know we had missing data. If there was a bizarre price spike, we would know something was wrong with our data. It's coming from Yahoo Finance in this case, so that's not as big a concern, but if this was some alternative data set that we'd never worked with before, it would be a good idea to just throw some sort of a visualization together and take a look at it to make sure things look about how we were expecting, or maybe we had no expectations for how they would look, but we want to get a feel for it. So this can save you a lot of time at the end of your project when you go through everything and run your model and realize there was missing data. So just one quick chart just for yourself. So similar chart. We're going to use HighChart for this one just to look at a different visualization tool. Similar, this is again an interactive chart where we can kind of hover and see what's going on. This can kind of be thought of as almost maybe between exploratory data and just kind of verification, just getting a quick snapshot of our data. All right, so those are just raw prices. Let's look at performance analytics a little bit, because if you're going to get started with R, this is the package that I personally would start with. It has a lot of really nice built-in functions that take a vector of prices or returns and gives us back something that's pretty interesting. We'll start with a simple one, return.calculate. This is just going to turn our prices into log returns. It's not a really complicated transformation to make, of course, but it's just nice to have the built-in function there waiting for us. Okay. This is another cool function. I start a lot of my work with this one. It's called table.stats. You can see it's just 2 words, table.stats. We're passing it in 5 columns of returns, but we could pass it 50 columns of returns, and that would be the same thing, of course. It's just going to let us glance at our data. And we'll notice some important things. One, the number of observations is the same for all 5 of our ETFs. That's what we wanted. If there was a discrepancy there, we would need to do some imputing or some cleaning, but always good to start at the top. Is there a consistent number of observations? It's telling us there's 1 in A because we calculated returns. Gives us some interesting things to look at down here: standard deviation, skewness, and kurtosis. Just when I first just glanced at this, I thought it was weird that IFA has a kurtosis of almost 9. I wasn't really expecting that, but this is just a really nice way to get a snapshot of our data and make sure everything looks about how we were expecting it to look. Getting a little bit more analytical, there's this table.capm function. Again, it's a pretty quick call out. Because it's going to run a simple regression for us, we have to give it a reference. We have to tell it that we want SPY to be our quote-unquote market return here. But other than that, we can pass in our data frame of returns, and we're going to get back this. We have a column on the far right, which is SPY to SPY. So we should see all 0s and 1s there, which we do, which is nice. And other than that, it's just very quickly calculated a beta for us for those other 4 ETFs. I think it's about what we were expecting, around 1 for EEM and IFA, negative beta for AGG, which is a bond fund. Kicks out a correlation. And I mean, these are really just kind of our exploratory statistics. We want to make sure things tend to look how we thought they were going to look. And then I think it's a good idea to take a pause from the tables and go with the visualization. And I also just wanted to show you all a little bit of the code from ggplot and how you would create a plot using ggplot. We'll create a scatter of, in this case, it's just going to be 4 out of our 5 ETFs because, well, we regressed SPY in itself. There's not much really to visualize there. But again, we want to glance at this. I would say this is getting a little more to the exploratory phase. We're trying to visualize and confirm that there is some sort of relationship visually that we saw in the previous table, and I think this tends to support that. These look pretty strongly linearly, actually, except for AGG. So if we think of this as kind of exploratory data, I'll make sure everyone sees the link at the back of this, but there was recently an article written about this quant fund up in Canada, which is fully data science and very, very machine learning heavy. The article just talks about where they tend to spend a lot of their time. And exploratory analysis like this is where they spend an inordinate amount of time. They happen to use R for it, though they're a multilingual shop, a lot of C++ and Python and R, but they spend a lot of time exploring their data. Before they start fitting algorithms, they do things like this, which probably seems pretty simple, but in the data science world, this is what we do a lot of. Exploring data, looking for patterns. If you have a 6-month machine learning project, you might spend 5 of it just doing this before you actually fit any sort of model and pull out any results. So this is, of course, just a simple scatter plot, but I like to include it so that we kind of focus in on exploring our data, even if we're very confident of the relationships. And ggplot has a pretty fast way to add in a regressor line here. Since we said SE true is going to include the standard errors. One of the nice things about this, I think, is that we're doing this for 4 ETFs, but this is generalizable to 50 ETFs. The code would be really the exact same. If we had just passed in our original vector and had 50 tickers in it, we would have 50 charts here that we could scroll through and be looking for relationships. So this code can very, very quickly be scaled up. Or we could pass it into something like this where we give our own tickers. So this I'm just entering in EEM and then I'm specifying the one I want, whereas here I would just make my vector hold more ETFs. Similar chart to what we just saw, this is going to be an interactive chart using H-charts. This is a little bit more manual in the sense that there's not an off-the-rack way to do all of our ETFs at the same time. We have to do them one at a time. So we might want to start here. Let's imagine we were visualizing 20 ETFs and one of them seemed a little bit unusual to us, or maybe we just saw some outliers that we wanted to explore and say EEM. Maybe we're wondering what that is. We can go to a more interactive chart and we can hover on it and we can have it display whatever information we want. In this case, it's just displaying the date, but this could kick to any sort of data we want it to display. So that's kind of the reason that these interactive charts can become more powerful. We can more compactly display a lot more data because each of these dots is representing the relationship on the X and the Y axis, of course, market returns and EEM returns. But when you hover on the dot, it's almost like unlocking it and opening it up, so it can be holding a lot more data in there. And the next step would be to have another chart beneath this that when we click this dot, the data from that dot is displayed down there. So you can kind of build iteratively on these things. All right, so similar to how we couldn't, right out of the box, visualize all 4 ETFs there, we also can't really add a regressor very easily, but that's okay because it gives us a chance to look at how we can make use of that table.capm calculation that we ran earlier. So table.capm returned a whole lot of numbers for us, one of which was beta, and beta is the slope of the line that we want to chart here. So we can pull out that number from table.capm. Not extraordinarily complex, but it's just kind of an example of taking one built-in function, table.capm. It gives us a lot of possibly interesting numbers to think about. We can pull them out and use them with a chart and see how they look. So these things are not, the objects we're creating are not kind of contained within themselves. We can pull things out of them and mix and match these technologies as we want. All right, there's a lot of nice functions in performance analytics, probably 100 or more in there. They're all really useful. Table.downside risk is going to calculate semi-deviation, the downside deviation. It's going to have an assumed bar in there. There's a Sharpe ratio function where as long as we supply a risk-free rate, it will return the Sharpe ratio of all of our assets. Same for information ratio, as long as we give it a reference. There are a lot, so they'll, when I send out the slides for this later, if you want to explore them, there's probably 100 of them. Very nice stuff. There's one more I want to go through though, because I think it's an interesting example of the R ecosystem and kind of how it's gotten built up. So there's a function in performance analytics called standard deviation. It's called std_dev, but it stands for standard deviation. And in base R, there's already a standard deviation function, SD, because whoever built base R 25 years ago, John Chambers, knew we needed a standard deviation function. But the base R function was not optimized or built for finance in any way. So the performance analytics guys built a standard deviation function that is optimized for it. So if you call stdev on our returns, it'll give us the standard deviation of each of the returns as we were expecting. But it has kind of a nice built-in feature, which is that if we want to combine those 5 ETFs into one portfolio, we can just pass in a vector of weights. And this function is smart enough to know that we're now building a portfolio. We didn't have to tell it this is a portfolio. We didn't really have to tell it very much at all. We just had to give it weights, and it's going to know that we're building a weighted portfolio of these 5 ETFs. So again, we could generalize this to a lot more ETFs and a lot more weights, and it's going to kick back the standard deviation of returns of this portfolio that we just built. It's kind of cool that we can do that so fast. We can also tell it, build a portfolio of those weights, and now return to me the contribution to standard deviation of each of those assets. So I think we're getting a little bit deeper into what we can do here, and so now it's going to kick out 5 numbers for us, and you can, as we were probably expecting, AGG, the bond fund, has a negative contribution to standard deviation. But I like to include this slide just to show that there was already a standard deviation function in base R. And we could have written a function that did all of this ourselves, but the builders of performance analytics realized that this is something that people who analyze portfolios do frequently, so let's make their lives easier and allow them to do it with just a few commands. It's a nice flow, and it's true of a lot of the functions in this package. They've been purpose-built for us, which is very nice. Then from there we could go on. We could visualize these contributions by pulling them out, popping them into ggplot, and well, putting together a bar chart here to show the relative contributions. You can see AGG doesn't even show up. Same thing with hchart, which is part of the high charter package. I like this one better because when I hover, it actually shows me stuff. Once you get used to kind of hovering on a chart and seeing something happen, it's hard to go back to this where if you hover, nothing happens. So I tend to default to this at the end of the day. All right. So let's leave performance analytics where there's a lot of built-in functions. Like I said, there's probably 100, maybe more. When I send out the slides, I encourage everyone to go check them out. Email me if you have any questions about how to use them. But let's touch a little bit on building our own functions and how we would apply those, because that's often going to be the last 5% of any project, our own functions, our own analysis, so we can build our own charts and make them look exactly how we want. All right, let's assume we want to calculate maybe the rolling mean of one of our ETF prices. In this case, we'll go with SPY, the S&P 500 ETF. Well, there's a built-in function in base R called mean, just like there's a built-in function called SD, and here it is. And then some very clever guy built a function called rollify, which allows us to turn these functions into rolling functions. So with the addition of this word rollify and the window, in this case 50 and 200, we can create our own rolling functions. It's a pretty fast way to go about doing things, and we could do this with correlations, we could do it with covariances. There's some functions that don't like to be rollified, so you have to do a little bit of data slicing, but rollify is a really good way to get started with making your functions rollable. It sits in a package called TibbleTime, which if you grab these slides, you'll see that you'll need to load the TibbleTime package, but it's a pretty easy to work with function. And once we have rollify, we've defined our own functions, we can run our calculation the same as we did before. We're gonna rollify SPY prices 50. We're gonna rollify them by 200. So there's a line in here called signal, which says if else SMA 50 is greater than SMA 200 0. This is for if I give this presentation for people who are looking for very simple trading signals. But it's also a way to which most people aren't, but it's also a way to convert prices into binary classifiers. And I've seen some people do some pretty interesting things with that. So converting things into ones and zeros, you never know where that's going to lead you. And this if-else function is a really good way to do it. It's going to compare the value in one vector to the value in another vector, and then give you a 1 or a 0 depending on the relationship between those two. All right, and then from there we pop it into this visualization. I know it's probably hard for everyone to see this, but the blue line here is the rolling 200-day average, the green line is the rolling 50-day average, and that dotted red line is the actual price of SPY. So we were able to take this rollify workflow where we're calculating a rolling mean and a rolling standard deviation, and then pop it into our own visualization. And like before, we could have started with a lot more vectors and just cranked these through the functions and created 50 of these. But for a chart like this, I think this is where shining probably makes more sense. So we start off here creating maybe a visualization that we like. Maybe we think this is interesting and maybe we're interested to explore how this would look for other assets. Then we can just pop it into a Shiny application, and so that we, or really anyone, can come enter whatever ticker they want in here and see how the relationship plays out between the 50-day moving average and the 200-day moving average. And of course, we can add complications to this visualization if we please. I also like to include some of the base stats down here. The return stats, this is from table.stats. These are the drawdowns for whatever we enter into this little ticker entry here. Okay. All right. I don't normally include these, but over the last few weeks, machine learning has just become so buzzy and so popular, and everyone's talking about it, that I decided to add a slide on machine learning, just to talk about how it works in the R world. Similar to a lot of the other things we've been seeing, there's a lot of packages that have been built to help us fit machine learning models. This is just a call out of a couple of them. H2O is a company that builds open source software. It uses a Java compiler underneath what it's doing. Keras is for more deep learning. Rangers for people who want to get into random forest algorithms. So they're all here. The one I want to call out as being very important is LIME. So library LIME. LIME stands for locally interpretable machine. I can't even remember the last of it. But basically, it's for interpreting your machine learning algorithms, because machine learning is, I think, getting a lot of popularity. It's also getting a lot of, not backlash, but maybe a little bit of skepticism over being a black box, and LIME tries to white box machine learning algorithms so we can try to pull out some of the relationships in different areas of the chart. But this is a pretty good snapshot of getting started with machine learning in R, if that's something you want to explore. Recipes is for pre-processing data, and RSample is for splitting your data between training and testing sets, which is kind of the first step to most machine learning. Like I said, an article just came out about a really cool high-performance data science team at this hedge fund up in Canada. This is a link to the article, so I'll send this out to everyone. But it really walks through their workflow, data ingestion, data processing, exploratory data, when do things like machine learning come into play, when do they not come into play. It's a really good read from about a team that's actually doing this stuff, and they've been doing it for a long time. All right, well, if you want to learn more about R, Rex mentioned my book, Reproducible Finance with R. That'll be out in a few weeks. Email me if you want a copy. I'll try to get you one if it's not sold out. I should be able to. Then there's R for data science, and this is like the Bible of R programming. It's a great way to get started. You can buy it on Amazon for 20 bucks. It's free online, R for data science. It's a really good read. If you have a project that you want to work on, this is a great way to get started. Open up the web page for R for data science, open up your project, and see how they map onto each other. If you do want to get started with R coding, here's basically the steps you would need to take. You need to download R, the R kernel, onto your desktop, which you can do tonight if you want. It's all free. I would recommend to download RStudio, which is this IDE, or else you'll be coding from the command line, which is a little bit difficult. One course that I found pretty useful is DataCamp. I don't know if people are familiar with DataCamp, but they have a whole track on applied finance with R. I think I've written a DataCamp course. I think it's actually more like 6 or 7 courses. But the intro course on there, I believe, is free, and it's just kind of a good look at the landscape and a good way to see if R is something that you're really interested in pursuing. All right, well, that's it, guys. Thanks very much for coming out today. I appreciate it. If there's any questions, happy to field those about R or data science or programming. That's it. Yes?
This is maybe an odd question, but I'm just trying to get my head around where you do certain things. So you pull daily data in on a bunch of ETFs and then calculate standard deviations. You got daily standard deviations.
Right.
But if you wanted annual standard deviations, you can't just scale that up because you've got zero correlation. So you need the annual data or monthly data or something, depending on what you're doing. You have to go back to the data import and re-import new data, or is there a way that R can say, okay, but only give me the last day of every month?
Yeah, there's two ways you can do that. So there's a function called toMonthly, to.monthly. There's one called to.yearly. And what you would do is you would apply that function to the daily prices, you would apply the function to the daily prices, and you would tell it which side you want it to go to. It'll ask you, do you want to use the first day of the month or the last day of the month? Okay. Oh, so sorry, for everyone who couldn't hear, the question was, how do you convert between, say, daily prices to weekly or monthly or yearly? And there's built-in functions for doing that. We actually could have started our import with that. We could have said, let's import something like monthly prices, but in general, I would say it's better to get the raw data and as detailed a data as you can, and then do that conversion yourself, so that if you ever need to go back and change it, you can. Yeah, good question. Yes?
So when you're using, and I'm not a computer guy here, when you're using other people's kind of functions or built packages like to.monthly or something, I'm going, oh, okay, that's taking the last day of the month. Well, how do you know that it's really not taking the first day of the month and you're really not getting what you think you are?
Right. So the question was, if you're using a built-in function like to.monthly or anything, how do you know you're getting what you were expecting? So there's a few ways that you can test, and this is kind of called unit testing in the coding world, and you can think of it very similar to almost like double entry accounting. And what that means is that if you were to a stage in your project that you wanted to check that, in other words, you weren't just doing exploratory data, you would do an independent run of that. And you would call that a unit test, and you would save it somewhere. And say, this is how I run my unit tests of to.monthly. Right? Because you could explicitly write a function that says, find the last day of every month, bring it over into this data frame, and then bring over the price. Right? So if you did write that function, you would want to save it. And then every time you wanted to test to.monthly, you would want to use it. And then every time someone on your team wanted to test to.monthly, they would want to use that function. And that's similar to, like, let's say, standard deviation. You could just write the math out that says, give me distance from the mean for every observation, divide and conquer. So, and then you would save that as something called like to.monthly-unit test, and that would be your testing. But typically that would be when you're ready to take this into something like production, where you're really ready for other people to start using it. And honestly, once you've done it once you've got that function written yourself, you've got it, and you can reuse it and reuse it and reuse it. Yeah, good question. Another question? Yes?
How does RStudio handle its version controls?
You mean the version of our own software?
Well, version of your own software, how a developer would handle its version.
Yeah, so a developer would still use GitHub. So we have a Git integration, which you can't really see. I can maybe move this over. But you would use Git or Subversion, similar to how you would do with any programming language.
Okay.
Yeah, and there's a direct integration from the IDE into GitHub and Subversion.
Okay.
And that's, let's say 99% of people are using those too. Yeah, usually on like a private GitHub repository they've set up somewhere.
Yeah.
Yeah, good question though. Similar for packages, by the way. So these packages go through evolutions, and new versions of them will come out. And you'll want to archive and keep track of the different package versions that you're using. Yep. Question over here?
Just a curiosity, from your seat, what are you seeing as some of the more interesting applications of, I guess, RStudio with the teams that use the product and work with it, whether it's finance or other industries?
Sure. So in finance, I can tell you one very recent use case that just came out, which was a team that they're using NLP and text classification, and they're scraping I believe they're only scraping Chinese news outlets right now. And they're just scraping through the words and scraping through the words, and they're using it to enhance their credit ratings for these companies, basically, because they are skeptical of public data that's being reported. So they're finding that if they can grab enough words, and yeah, the interesting thing about this team is that none of them speak Chinese. They went out and they, so speaking of unit testing, people ask, how do you know you're right? The algorithm's right. That's a really, really cool use case, and it can be generalized to other countries as well, too. And they're, actually that brings up, so that's a really cool use case, and we can talk more about how they did that, but it brings up another, I think, really interesting area, which is that they filed a patent on that technology right now. And I think that's going to be a really fascinating field to keep our eyes on. Google and Facebook, they're patenting a lot of their algorithms that they're running right now. And it's not getting a whole lot of press, but I think it's kind of an interesting thing to think about, that these algorithms, they're being open source, but then they have their own closed source versions that they're also filing patents on. And I wonder where that will leave us in 5 or 10 years, but who knows. Yes? Yeah, sorry.
Yeah, I'm a little bit surprised that no one asked that question yet, but R versus Python.
Right, yeah.
In full disclosure, I played with R and Python in the beginning, and I stuck with Python. There's no like scientific explanation why. It just seemed a little bit easier for me to pick up and wrap my head around as a non-computer science degree kind of person.
So I promised that if someone asked this question, I would let Rex have a turn, but I'm going to give my answer first. So I would say there's no objective yes or no answer to whether R or Python is better. I can only speak to why I like R better. And kind of similar to what you said, actually, I found R to be much easier to pick up for someone who doesn't have a computer science background. I found the syntax to be much simpler and the package system to be a little bit easier to wrap my head around. It's also, like I said on the very first slide, it's kind of a data science oriented language. So you don't have to worry about a lot of the general computing concepts and theory that come along with Python. So I found R to be much easier to pick up and much faster. And if I had to choose one objective area where I think R is better than Python, I'm not supposed to say this, but I think the data visualization packages in R, they're stronger, there's more being developed, and it's easier to pop them into something like Shiny and make them accessible to the world. So that's kind of how I view the R versus Python thing. Interestingly enough, the guy who invented pandas, Wes McKinney, he recently joined RStudio, and we're working on a project called Ursa Labs, because he has bear themes to everything that he does, evidently. But he's working on something called Ursa Labs to make Python and R more interoperable, and kind of increase the ability to share data objects back and forth. Because what we're really seeing is that a lot of quant teams use both, and they just kind of hire the best people they can find. And if they happen to prefer R, they give them the R tooling. If they happen to prefer Python, they give them the Python tooling. It's kind of hard to jump into that debate because everyone has their preferences, and I've never seen anyone be convinced to switch programming languages in my career. Rex, you want to add to that? Or have anything? Yeah. I wasn't joking. I bet you was.
No, and I'll say this, that as a guy who learned not only sort of assembly language, but Fortran and COBOL, I don't really expect Python or R to necessarily be what you're going to want to use in 10 or 15 years anyway. So these things, programming is still dynamic, it changes, the languages change. So I wouldn't get too hung up on it. Whatever you do in one, you can do in the other. But I will say this, when I think of programming languages, and I think of this audience, and so you can go Google Python versus R, but I want to talk to this audience who really are financial analysts, let's say, first, and you're using a tool. You're not a programmer first, you're probably a financial analyst first. So you're not the general population learning to code. So I think of programming languages as existing between the computer and our brain, and we want to communicate to the computer. And then you can use assembly language, which is very close, and you can move on up. And now The highest level programming I know is when you go, okay, Google, what time is it, right? That's getting really high level. What I would argue is that R is a little bit closer to the way we communicate than the way Python does it. And I'll give you a couple of examples. If I have this vector, and I want the first, and Polina, correct me if I'm wrong, if I want the first 5 vectors, a vector called x, I could just go kind of x1 to 5 in R, because I count 1, 2, 3, 4, 5. That's the way I learned to count. Now in Python, if you want 5 elements, I think you have to go from 0 to 5. You actually get it 6 numbers, 0 to 5 is 6. And it excludes the last one and gives you the first one, which is number 0. And that's not the way I count. Okay, so this is why I think that R is closer to the way we do it. Other things can go weird. For programmers, it's fine. If you really have a strong programming language background, Python's great. But if you say like x equals 3, y equals x, and then you want to say change one, you may end up changing y when you didn't mean to. There's some referencing. So I just think R is a little bit higher level language than Python, and that's why I advocate for it at this point. But we'll see what happens.
All right, any other questions? I think we're about up on time. Yeah? All right, oh, one more, yeah?
Is there a way to create an infectable file or to run the R script without RStudio?
Yeah. I mean, you could schedule these as cron jobs basically, and just have the computer run them on the R kernel on your screen. So if you wanted to schedule jobs to run, you wouldn't need to open RStudio. You would probably come to RStudio and write your scripts the way you want them, and then save them as an executable and schedule them.
Once you create a set of data, does R have a way to update that data on its own? There's
Well,
something like online where you could grab that.
Yeah, so similar to that question, you would kind of tell the code, as long as you have the code wired up, so for example, we have this thing that's telling it to go out and get data from Yahoo. We could schedule that script to run every day, and then just plunk it into a database, or create a spreadsheet and then save the spreadsheet for us. So you would code that up in R. There is a tool that we have where you can just schedule things, but that's more for if you wanted to schedule like a report or something. If you're just updating your data, then you would probably schedule that job to run. You would probably run it as an executable. But yes, if you have more questions about that, let me know.
How are you going to send out information to, say you're going to share this information with us? How are you going to follow that?
I'm going to email these slides to Kathy or Natalia. But feel free to email me also, and then I'll send them to you. All right, thanks everyone. I really appreciate it.